Good morning, good afternoon, good evening. Welcome to vSphere Live, where we talk about, VMware vSphere, and we answer questions live, all that sort of stuff. I'm proud to do another one of these. We've done quite a number of them over the last couple of years, but October is always a special time in the U.S. because it is Cybersecurity Awareness Month, and so we're doing one of these a week, talking about different things. And so, like I said, my name is Bob Plankers. I'm a staff technical marketing architect at VMware. Don't be put off by the marketing in my title. We are technical people that help a lot of the different folks in the different areas of the VMware ecosystem figure things out. I help people figure out security and compliance, mostly, but vSphere in general, that sort of thing. Before we get started here, we're streaming live on YouTube, our YouTube channel, the VMware vSphere channel, but also we've got stuff going on Twitter, we've got stuff going on LinkedIn and on Facebook as well. I'm using a tool called StreamYard to aggregate all the comments together, and so if you're leaving comments, I think comments in most places, if you leave a comment, I will or a question, if you got a question, I'll repeat it for the whole stream, because the different sides of things can't see each other. If you're not seeing, I'm pretty quick about answering questions, so if you're not seeing me answer your question, come on over to the YouTube side of things and enter put it in the chat there. But other than that, if you've got questions, comments, thoughts about this stuff, please put them out here, and yeah, we'll get started. I'm not bound by time here. A lot of these presentations go for an hour, but an hour is pretty restrictive when it comes to talking about a lot of these different things. So I'm going to go until we're done. If we don't have questions or whatever, then it'll be shorter, but whatever. So before I get started, my obligatory disclaimer here. This is not the normal VMware Explorer disclaimer or whatever. This means this one is a fancy way of saying context matters. Security, anytime we're talking about security is something you need to work out for your own organization. We've got some good ideas at VMware, but they might not be good ideas for you, or they might not go far enough either. And that's the other thing too. So, yeah. And then some housekeeping too. We've got, I was saying earlier that this is one in a series of events. The next one is going to be next Thursday. Next week, Thursday, October 19th, 11 a.m. Pacific. My coworker, Viviana, is going to be talking about authentication and identity providers in VMware vSphere 8. There's a lot of interesting stuff going on there. We've got Okta support, Azure AD, now Entra ID. Microsoft renamed it on us. And how dare they change something without consulting us first? But I kid, of course, but in fact, I'll talk about Microsoft a lot in this presentation because we're going to focus on Active Directory, but a lot of these techniques are generalized. But anyhow, authentication identity next week. I also want to give a shout out to the VMware Security Day, which is coming this Thursday in 2 days, Thursday, October 12th. And it's all virtual event. I've got 2 sessions there, a professional development one and a hardening one. The hardening one is a subset of what we talked about last week, which is a recording on our YouTube channel. If you didn't catch it, we have 90 plus minutes of talking about, and that's part 1. I'm going to do a part 2 at the end of the month here. And, a lot of this stuff could be a 2-day workshop when it comes to system design and all that stuff. And so at any rate, and pardon the hat, this is actually a VMUG hat. Somebody in the VMUG community made this a number of years ago as a fundraiser to support a charity. And I've got a little bit of a headache, so I'm hoping it helps with the light a little bit. So pardon the hat, but yeah, always a pleasure to work with VMUG, and please support your local VMUGs too. So let's talk a little bit about what we're going to talk about, get actually into the meat of today's presentation, protecting Active Directory using VMware Cloud infrastructure. When VMware has gone back and forth on the whole cloud thing, VMware Cloud is a public cloud-based offering, but VMware Cloud, we're renaming a lot of what, vSphere and that to be cloud infrastructure. And so don't be put off by cloud infrastructure. I'm talking about ESXi. I'm talking about vCenter Server, vSphere. I might even mention NSX, but I'm going to focus on vSphere in the core of everything. But introduction to the scope of what we're talking about. Active Directory is a big topic. There's a lot of internals to it too that we might not want to get to. Security for guest operating systems. Active Directory. We're going to focus on Active Directory, but a lot of these techniques are equally applicable to any Windows guest operating system, a lot of Linux guest operating systems as well. And so you can choose what you want to do there. Infrastructure design ideas, not necessarily technical controls, but good ideas about resilience and things. That's something that vSphere can really help with, is resilience. And thank you, Sergey. The nice hat. I do like this hat. It's a very nice hat. I just found it the other day too. I've got a whole box of hats in my closet. Anyhow, I'm a man of many hats, and many in all of the ways. So anyhow, design ideas, and then we'll wrap up with some resources, which you're probably familiar with already, but we'll just reiterate those. So getting into it, Active Directory does a lot for organizations, and it's a little scary how much an organization might rely on it. DNS, obviously, time synchronization, identity federation. It's got a certificate authority in it and all that stuff, but we really focus on authentication and authorization. And these two things, authentication, the idea that, hey, I'm proving that I am Bob, and authorization, that it's got something in there that says Bob gets to be part of the VMware admins group, and so I get to be an admin. That's scary unto itself, because Active Directory becomes a big target for attackers. And this is actually one of the primary ways when we're contacted by a customer and they're saying that they've been breached, they've got ransomware, that sort of thing. Their corporate Active Directory is usually how it, or identity provider. I mean, there's been big news. I shouldn't pick on Active Directory, but identity providers in general. There's big news recently of a huge ransomware attack where they got in through a cloud-based identity provider. And so it's not just Active Directory, but it's a centralized stuff. So. But, and I don't want to talk about connecting vSphere to Active Directory. Vivian is going to talk about that next week. And so but I just want to caution people, Active Directory, doing the authorization and the authentication and the authorization in one spot can be very dangerous. And that makes it a really attractive target. So how do you secure it? Well, Microsoft. When I first joined VMware, a guy by the name of Mike Foley, my predecessor, talking about all this stuff, he suggested to me that, hey, Microsoft, gosh, I can't even talk anymore. Microsoft has got this best practices for Active Directory, website, documentation, and that it would be great if we had sort of an appendix for it, for how to secure it even more using vSphere. And so that's what I want to talk about today. There's all kinds of good ideas in securing the insides of Active Directory, and I'm not an Active Directory expert in that regard. I know some enough to be dangerous. I look at the documentation too, and the guidance there. There's all kinds of great resources out on Twitter and the internet and that for securing Active Directory, the insides of it, auditing it. There's all kinds of tools. Bloodhound is a great tool for assessing permissions and things like that. But even things like privileged access workstations, are they a great idea? Absolutely. In fact, they're probably a great idea even for vSphere itself. In managing a lot of this infrastructure, we need to really form a perimeter around it for management. But it's not something I want to talk about here. In fact, I talked about it last week, the isolation and things like that. What I do want to talk about is using vSphere features to protect things. And I always go back to the core tenets of information security, the CIA triad. Confidentiality, keeping unauthorized people out of our data. Integrity, the idea that when I leave data somewhere, I want to come back and have it be in the state I left it, or the state I expect it to be in, at least. And availability. What's the point of these systems if I can't use them when I need them, right? We often think of security as confidentiality, but integrity and availability are really important as well. And those are two areas that vSphere really shines, availability especially. So you can take every feature in vSphere, It's probably debatable. There's probably a GPU feature that you can argue or whatever, but you can take nearly every feature in vSphere and map it into one or more of these categories. And this is not a complete list of vSphere features by any means, but you get the point, right? And so everything becomes a security thing. And this is something you can do if you want to make improvements. This is how you sell it to your organization. You say, hey, I want to improve security by doing X. Who's going to argue against having additional security, right? So what sort of features are we going to talk about? Well, let's talk about Secure Boot. We'll go over that a little bit. There's a lot of folks that aren't using Secure Boot. Secure Boot's been around for 14 years now. We need to get on it. It helps prevent malware at startup. It's great for that. And there's a lot of stuff that would just stop, a lot of attacks that would just stop functioning if we just used Secure Boot everywhere. VBS, virtualization-based security, that's Microsoft's term for nesting hypervisors, using a little bit of Hyper-V to create a secure enclave to help protect Windows and Windows secrets. We'll talk about that. Data at rest encryption, vSAN encryption, VM encryption, even BitLocker. Is BitLocker a good idea on a VM? Well, in general, we don't recommend it necessarily, but Active Directory DCs are special cases, and they're worthy of going above and beyond a little bit too. So we'll talk about that. Virtual TPMs, a hot topic lately, especially with Windows 11. Have some resources for that. And then VMware tools. We can actually do a whole bunch of things, or actually tell VMware tools to not do a bunch of things when it comes to customizing the VM, running scripts, guest operations, things like that. And we've got a lot of that stuff in the security configuration and hardening guide that's out there as well. So let's get into it. Secure Boot. Secure Boot seems straightforward, but like I said, it's not everyone's using it. In fact, there's not I'd say maybe 50% of the people are using it. It does require EFI firmware, and and turn it on. If you're building new templates, turn them on. Turn it on. It's easy. It works well. Yeah, it needs nothing from the underlying hardware. If your ESXi host is not using Secure Boot, I would recommend that, but it's got nothing we're virtualized, right? The underlying hardware is completely abstracted from the VM itself. So you can turn this stuff on. Supported in Windows Server 2012 and newer. 2012 goes end of life, I think maybe today or Thursday or something like that. Not 100% sure, but please, if you're still running 2012, Windows Server 2012 R2, get it out of your environment. You're way overdue. So anyhow, lectures about patching aside, lectures about upgrades. I get it. Patching is thankless. Upgrades, thankless. You do get some features for it in that, but it's a lot of work in that. So, but where you can have an opportunity to do it, take that advantage, and use the new tools. VTPMs, virtual trusted platform modules. So TPM's trusted platform modules do three things. They are secure enclave for workload secrets. They're a random number generator to seed the operating system pseudo-random number generators. They seed it with entropy, and they help with machine identity. And so any one of those three things might be interesting to a workload, to a Windows server, to an application, to Linux, whatever. And so you can add a virtual TPM. It's a TPM 2.0. It's fully compatible with TPM 2.0. And you can just go in, and if you've got a key provider, and we'll talk about key providers in a second because it relies on VM encryption. To protect the secrets on disk, it encrypts the NVRAM file that's in the home directory of the VM. And so if you look in there, there's an NVRAM file that has firmware settings and that. It's also got the TPM data if you add a virtual TPM. And so to protect that, we encrypt it. To encrypt it, we need a key provider. Again, we'll talk about that in a second. And so if you've got a key provider configured, you don't have to do anything. All you have to do is just go to trusted platform modules, or to add new device, edit the VM, and the VM has to be off. TPMs in the real world, and TPMs in the real world look like this. They're tiny. It's probably out of focus. Sorry. Oops, and I dropped it. Look at that. It's about the length of the end of my pinky from the last knuckle on. And they're tiny. That's a hardware one. This has got nothing to do with hardware, though. The TPMs are All you have to do, they're not hot pluggable. They're in the physical world, they're a serial device. They sit on a system board. And so the VM needs to be off for two reasons. One, they're not hot pluggable to start with. And two, the VM encryption requires the VM to be off in order to encrypt the VM. And it's a very quick operation. You shut the VM down, add new device, add a trusted platform module, boom, save it. Couple seconds later, you're good. You can power it back on, away you go. And yeah, so that's that. Cloning. In vSphere 8, you get a choice of what you want to do when you clone a VM that's got a VTPM on it. You can copy the VTPM. So if you're doing it for backup purposes, or if somebody's doing an upgrade, an application admin's doing an upgrade or something like that, and you want to be able to roll back, that's without taking a snapshot necessarily, then you want an exact copy. But a lot of times when you're doing deployments, you don't want an exact copy. You want a fresh one. And so it'll offer to give you a new blank TPM, which is fully compatible with the Microsoft deployment toolkits and things like that. So very much like hardware. VMware really tries to do whatever physical hardware does. We just tried to do that in the virtual world as well. So yeah, cloning, the backups work just fine. VTPMs have been around since vSphere 6.7. And so backup providers have their way of dealing with them, that sort of thing. They're fully supported in most cases. VM cannot be exported to OVF or OVA format if it's got a VTPM on it. That's something in a roadmap, but and it's being worked on. But that's important safety tip there. You'll have to remove it in order to do that. It's really easy to add, though. It's super easy. And again, it does not depend on the hardware. So if your hosts, and not all virtualization platforms are like this. Some virtualization platforms actually pass the TPM through to the VM. We don't do that. I repeat, we don't do that. If we do that, when you do that, you tie the VM to that piece of hardware. And we don't want to do that because that would break vMotion. We want you to be able to move VMs around. We want you to be able to replicate them to another data center, that sort of thing. And so that's why completely virtual. We're a virtualization company. Abstract it completely away. So does not depend. Your hosts do not have to have a TPM in order to use a virtual TPM. So I mentioned key providers. You've got your choice of key providers. What does a key provider do? It provides encryption keys. Very straightforward. So there's a standard key provider, what we call the standard key provider. Oh, here, let me move my picture-in-picture thing here a little bit. Here, let's go down there. Hey, look at that. My fancy ATEM mini switcher here. But you've got your choice of key providers. Basically, the standard key provider has been around since vSphere 6.5 or so. It's an external KMS. And the external key management system speaks the KMIP protocol, key management interchange protocol, and you store and you get keys from there. It provides you a key, and then the key is stored in an external system. Well, that's a lot of complexity for a lot of organizations. So in vSphere 7, we added the native key provider, and that's just a vSphere basically taking care of itself. It's able to generate the keys for encryption and then store them locally. Actually, it's not storing them as a key derivation function. But yeah, it takes care of it all internally. It's easy to set up. I'll demo that in just a second. And then the last one is a trusted key provider. It builds on the standard key provider, but it gatekeeps access to the key provider based on whether the host is in a trustworthy state. Hosts that are running secure boot, ESXi hosts that have secure boot turned on and TPMs installed, physical TPMs installed, will undergo a host attestation process. So you'll see it in the security tab in vCenter Server. You'll see that the host passed attestation. That means it came up in a known good configuration. It's not running malware that we can tell. It's cryptographically sound. Everything is from known good sources, that sort of thing. And so if it passes attestation, then the trusted key provider will give it the secrets. If it doesn't pass attestation, you don't get any secrets. Sorry, thanks for playing. And that's the way it should be, but that's additional complexity. So I'm going to talk about native key provider a little bit. Native key provider, super easy to set up. This is a recording of me doing it on vSphere 7, but it's pretty much the same on vSphere 8. The look of the client is just a little bit different. I'm adding a native key provider. Give it a good name. Key providers are found based on their name, so you don't want name collisions. If you got a bunch of vCenters, you don't name them all the same. So I named mine after the vCenter server that I'm attaching it to. You need to back it up. So the first order of business is to back up the key provider, and you can pick a password to do that to secure the file. You want to keep a copy of this file because this is your lifeline. If something happens to your environment, there's no backdoors to this encryption. And so if something happens and you lose this key, it's like losing your keys to your, well, actually, I shouldn't say that. Actually, losing the keys to my truck would actually be easier to recover from. But yeah, save this file. It'll export it as a .p12 file. Save that somewhere safe in your data center, that sort of thing. And so, yeah, very easy. And from here, that's it. You just saw the whole thing there. And so from here, you can add a VTPM. Same sort of thing. I'm going to edit the settings on the VM itself. Add a new device, trusted platform module. I'm going to say OK. Boom. And then you're going to see it in a second or two. Yep, it's going to say the VM configuration files are encrypted, that NVRAM thing, and then it's going to show a little lock icon there, which I highlighted. So again, super easy, but there are considerations. If you're interested in this, I've got a ton of stuff. Every question, that's a bold statement. Most questions you may have, I've got a huge Q&A out there for native key provider and VTPMs on core.vmware.com. And a 10-minute video, actually, it's 12-minute video on how to set it up, the considerations for using it, that sort of thing. Well, what does this get you? Encryption. Speaking of encryption, so we use VM encryption a little bit for the VTPM, but we don't encrypt the whole VM. Well, what if we went a little bit further? What would that buy us? Well, the encryption really helps for data sanitization. Data at rest encryption is a physical security control. And here, let me move my thing back up here. There we go. And so what does encryption help with? Well, regulatory compliance. It's going to check a box. Those boxes are important. We make fun of regulatory compliance as not being security in that, but regulatory compliance is a business process. We got some questions coming through. Ahmad, yeah, it looks better. I'm assuming moving my face around here a little bit. There's a LinkedIn user that's asking, I missed the first 20 minutes. Will there be a recording? Yes, out on our YouTube channel, the VMware vSphere YouTube channel has recordings of all the VMware lives that we do. And except for one, there was one that was an absolute disaster. And I won't get into why that was. That's not out there anymore. But no big deal. They're all out there. Last week's hardening one, this week will be out there as well. So, yep, you can catch up. You can see the end of it if you have to go, that sort of thing. So, and yeah. So anyhow, where was I? Regulatory compliance. We make fun of that as not being security, but it's a business process. It's gatekeeping an industry. In order to take credit cards or run a hospital or a nuclear power plant or whatever, you have to pass a test, basically. And it's a test for your infrastructure. Are you doing a bare minimum amount of security in order to be part of this industry? And if you are, then you get a letter, an authority to operate. You can go ahead and take credit cards, that sort of thing. So that's important, but also protect secrets, and it's a life cycle thing. If you have to change out a drive or something, a drive fails, or you want to, at the end of the life of a host, of a server, you want to make sure that the data isn't accessible. Well, you just delete the secrets from it, delete the encryption keys, and nobody can recover the data, right? And so that's really important. The other big thing, and with world events evolving here, you might not have time, theft and other losses, somebody invading your country, all that stuff. Those things move fast, and the enemy gets a vote, and so that's an old saying, among military folks, the enemy gets a vote. And it's true here. So you might not have time. So you might not have time to sanitize things, do it right. So you need to architect your environment to protect from the risks that might be there. And encryption can help with that. So vSAN encryption. vSAN encryption, I don't want to talk too deeply about it. I promised vSphere in that, but vSAN's integral part of vSphere. It's an extra license thing, of course, but completely guest agnostic, and that's true of VM encryption as well. And the guest operating system doesn't know what's happening to it, and that's perfect. You don't have to worry about support. You don't even have to tell your vendor, your application vendor, that it's happening. I wouldn't even tell them. Just it is what it is. So if you want to protect, and this also means that if you want to protect that Windows NT 351 box that you got floating around that does your payroll or whatever, we've all got something really old floating around that does like a fire alarm system or whatever, you can protect it with this tool, and it doesn't even know. You don't have to worry about it. You don't need specialized storage. The self-encrypting drives, those have pros and cons to them as well, but you don't need them. It does require the key provider. We talked about that, and there's pros and cons to the different key providers. I'll let you check that out on your own. But the other big thing here, and I didn't actually mention it here, deduplication and compression is still an option. That's a big thing when you encrypt a VM using BitLocker or VM encryption. It becomes this big random blob of data, and that is effectively undedupable and uncompressible as well. And so on more traditional storage, fiber channel stuff, NVMe over fabrics, whatever, you're going to lose your deduplication advantages there. And so something to keep in mind. vSAN, if you're just doing vSAN encryption, data at rest encryption, you don't lose those advantages because it does the encryption at the level below the deduplication. So it can still compress, it can still dedupe, that sort of thing. So this is what it looks like when you edit the thing. You can specify a key provider. My key provider is just this is a screenshot from a vSphere 8 environment, but you can also choose data in transit encryption, which is really easy to turn on, and you can pick how often it rekeys everything. So yeah, very flexible and easy to use there. VM encryption, native to vSphere itself. A lot of the same benefits, guest agnostic, you don't need SEDs. Self-encrypting drives, that sort of thing. Works with vSAN encryption. So, do you want to do 2 levels of encryption? Well, no, but for a VTPM where you're just encrypting just the NVRAM file, works fine. I'll talk about performance in just a second here. It enables the VTM. The VM has to be off in order to encrypt, to add encryption. The first time it encrypts a VM, the VM has to be off during that process. So if you've got a new VM, or if you've got an old VM that's huge, that might be a fairly sizable outage, but you can do it right in place. It will require twice as much space as a copy. It'll basically make a copy of the VM, so it requires twice as much space temporarily while it's doing that. And so something to keep in mind. But there's also some tricks if you've got a big VM. If you add an encrypted, because VM encryption is granular, you can say that you want to encrypt one VMDK file but not another one. And so if you add a new blank encrypted VMDK file or hard disk or whatever to the VM, that encrypts just like that. And so because there's no data there, right? And so if you've got a lot of applications, a lot of databases, file servers, if you're using logical volume management on your Linux box or your Windows box, you can actually do the migration while the VM is up and operational to the encrypted data store there, not data store, to the VMDK file rather. So just something to keep in mind, but some tips and tricks for that. I mentioned BitLocker earlier. Can you use BitLocker to protect your domain controllers? Absolutely, and it actually might be a good idea. You think about a rogue admin, and that's one of the big concerns for protecting a workload, protecting Active Directory. Rogue admin. Somebody gets into your corporate Active Directory, adds themselves to the VMware admins, the ubiquitous VMware admins group, and then they can log in as an admin to vSphere, and they can shut off your security controls. They can do all that stuff. How do you protect the workload itself from a malicious infrastructure or malicious operator of the infrastructure? Something we're deeply thinking about very hard at VMware, but BitLocker at the domain controller level might be a really good option. So if somebody exfiltrates, because exfiltration, basically taking a copy of your VM, take a snapshot of your VM and they copy it out somewhere so that they can hack on it, run crackers against it, all that stuff in their own lab on their own time, without the chance that you and your corporate security folks might notice, and that's the scary part. So how can we deny them that capability? Well, and make it so that whatever they copy out isn't going to work for them. Well, BitLocker might be a good choice there. Don't store your BitLocker keys, though, in your corporate Active Directory instances. Escrowing them there, they might become accessible to the attacker. If they've got that level of access, well, that's troublesome. One of the things that I've seen and actually had suggested to me at one point is the pre-boot enhanced PIN. So this could be an operational problem, for a domain controller that's rebooting. It'll prompt for a PIN in order to unlock the system. And so, that's an added security control. But again, it's an operational concern because the VM won't reboot on its own at this point, and so some human needs to shepherd it through patching and things like that. And does that stink? Yeah, patching again is thankless or whatever, but these are very critical systems, and so it might be worth doing that. But context matters, like we were talking about at the beginning. And so, let's see, we've got Neri with a comment out here, a question. If you do encryption at the vSAN level, what are the advantages to add BitLocker? Well, that's interesting, actually. Basically, vSAN encryption doesn't really protect against the rogue admin situation. Somebody breaks into vSphere and that they can make a copy of the VM. The VM itself isn't encrypted. So in-guest encryption like BitLocker or DMCrypt on a Linux box will actually help prevent a rogue admin from being able to access the data in that VM. But it's harder to manage. It's harder to, you have to manage it on an individual basis. There's operational concerns, that sort of thing. vSAN encryption is nice because you can just turn it on and stop worrying about it. VM encryption, same sort of thing. It's a little bit more granular, but you can manage it all as one. You don't have to worry about operating system by operating system considerations there. And so, that's the big thing, who you're protecting against. And Active Directory domain controllers, again, are such a high profile thing that you might want to do it a little differently. There's also, when you turn on VM encryption, you get cryptographic operations permissions in vCenter Server. And so you can actually deny people the ability to decrypt a VM. You can deny people the ability to, to change KMSs or any of that sort of stuff. There's a number of organizations that actually deny everybody that right. They create one super user that can do all that stuff. And that account information is stored in their password vault. Their password vault is set so whoever checks it out, it emails everybody. Hey, Bob is about to do something. Bob just checked out the crypto super user, that sort of thing. Something to think about. Like visibility into malicious things happening is a good thing. But so if you do set cryptographic operations, you need to do a little bit of testing, vMotions, cloning, storage, that sort of thing. You need to make sure that your environment can support that. If you are, the nice thing about, pardon me just a second. The nice thing about the permission model, or the permission model for any role-based access control permission model is complicated. But if you're missing a permission, vCenter Server will actually tell you what you're missing. If you try to do something that you didn't have permission for, it'll tell you right in the log what it's missing. So that's nice. Get a question once in a while. Can we do vSAN encryption, VM encryption, and BitLocker all together? And the answer is absolutely. But why? And the security is always a trade-off. I said security always depends on the context. Second big rule is security is always a trade-off, and performance is a trade-off. The second big question we get is, what's the performance loss? And we can't tell you. The universal IT answer of it depends, it still holds here. It depends on your workload, depends on how much you're writing to disk, depends on how fast your servers are, and all of that stuff. And so, so test things, try it out, and monitor performance. And so if you want to do BitLocker on top of vSAN, maybe you want to do vSAN vSAN encryption for everything, but also want to add BitLocker to just your Active Directory DCs, just try it out. Double encryption on modern hardware isn't that performance isn't going to kill your performance necessarily. So give it a shot, try it out, see what happens. And I mean, you can always unencrypt it again later, that sort of thing. And so do it to one of your DCs, monitor it, make sure, and just, and then do rolling upgrades from there on. VBS, virtualization-based security. I had mentioned that's Microsoft's term for, Microsoft also calls it HVCI, hypervisor, code integrity. It enables device guard and credential guard, a lot of the Windows integrity protections. This kind of came to a head with Windows 11, needing TPMs and having a lot of the stuff turned on by default. But Windows Server doesn't necessarily have it on by default, but you can turn it on. And so when you're creating a VM, if you create it initially, the wizard will prompt you, enable VBS, Windows Virtualization-Based Security. You can also go in after the fact and edit the settings. There's a VBS button there. But if you add it to an already existing VM, it's going to change the VM hardware configuration. So again, take a snapshot. The mitigation there is take a snapshot, add it. If your whole VM blows up, you can just revert the snapshot, no problem. A snapshot isn't just disks; it also captures VM hardware configurations, including the VM hardware version too. So if you want to upgrade from like VM hardware 13 to 21 and the latest versions of vSphere 8, you can take a snapshot, and if it doesn't work, you can revert it. So makes it easy to test. What VBS is doing, it's using a little bit of Hyper-V. And Hyper-V to create a secure enclave. You know how we talked about a TPM being a secure enclave for secrets, for workloads and such? Well, this is doing the same thing inside of Windows. Windows runs kind of in a virtual container, and then there's another virtual container, a virtual secure enclave that Windows can store its secrets in. And it's harder for an attacker to get in there, that sort of thing. And so doesn't necessarily require VTPM. The Windows tools will throw out big red flags or whatever and then offer to continue, but that's completely up to you. Most organizations are using VTPM, especially with native key provider. It's really easy to use and turn on. So most people are doing it that way. One of the interesting things, and Microsoft used to, in fact, they updated their documentation based on some feedback from me, and I appreciate that. Thank you, Microsoft. Was that Credential Guard used to not be supported at all. Now it's not. Now it's just not recommended on domain controllers. Mostly, and you can look this up. Just search for Credential Guard requirements. And you'll find the learn.microsoft.com site, their new documentation site name, that's got this stuff in it. And so it's not recommended. It doesn't provide any additional security to domain controllers and can cause application compatibility issues. Okay. And then they go on, things that need NTLM version 1. Please shut that off if you're running it. My goodness, but but yeah, you can read through it and decide if it's good for you or not, Oh, we got a question from George. BitLocker is one way to provide some level of protection from vSphere admins, bad ones or good ones. Any other suggestions besides configuring physical domain controllers? I've got a lot of hardening suggestions, but a rogue admin is a tough one, just like domain admins, especially if you're doing authorization in Active Directory, in a central directory, your domain admins are de facto admins for every system in your organization, so splitting that up and building isolation in there, protecting the infrastructure itself is really important. Building a strong foundation for the workloads to run on is really important. And I talk about hardening. I talked about hardening last week. There's a recording out on the YouTube channel for it. I'll talk about the part 2 of that in a couple of weeks here as well. And but that's a tough one. Only let people into vCenter server that you truly trust. Monitor the heck out of it, lock down ESXi, all those recommendations. Those are it. Physical domain controllers might be a good idea from a dependency perspective. I'll talk about that towards the end of this talk here, and maybe virtualizing things. Sometimes the answer is we shouldn't virtualize it, especially if that's your DNS if that's your time synchronization, that sort of thing. And that stuff needs to come up first after a power outage or whatever. That stuff needs to come up first in order to allow everything else to boot, your vSphere environment to boot. And so you don't want circular dependencies there. And, so, do I work for VMware? Yes. Do I believe in VMware technology? Absolutely. Should everything be in it? That depends, right? So anyhow, so domain controllers, it doesn't protect the Active Directory database itself. It doesn't, there's a lot of caveats here. So if you want to turn it on to make everything uniform and look the same, I completely support that. I always appreciated that when I was doing this stuff for many, many years. But up to you. To turn it on, and assuming you want to turn it on, you enable it in the virtual hardware, and you need to shut the VM off to do that because you're gonna change the hardware configuration. If it's you don't have to enable credential guard. That's a simple fix. But if you want to enable it, or you want to enable it elsewhere, I said that I would. All these techniques are generally applicable to other workloads. It's a group policy, and it's the same as any other Windows box, physical, virtual, whatever. You go into group policy, you enable it. You can change the settings for it, platform security level, enabled with UEFI lock, for example. If you set it without UEFI lock, there's some options there. Read through them, but a bunch of the options are such that if you set them without the UEFI lock, an attacker that gets in there can just shut it off. Shut off the protections. Well, what good is that if an attacker can just shut the protections off? And so, and I realize that they can do that in vSphere too, and we're working on dealing with that. But so turn these things on. Turn it on as secure as you can get it. One thing to note, there's really old documentation. When this first came out, you needed to install Hyper-V, the Hyper-V components. You don't need to do that anymore. If you're trying to do this and you find some blog article somewhere that tells you to install Hyper-V, go find a newer source of documentation, because you do not need that. Or just skip forward. You do not need to install Hyper-V. Windows takes care of itself in that regard. So some considerations for VBS. Apparently I don't have icons. Sorry about that. Performance. It's nested hypervisors. So performance, security is always a trade-off, right? You're going to lose some performance. How much performance? Same answer as before. It depends. Depends on what you're doing. Depends on your hardware. So use the newest hardware you can. If you've got old hardware and new hardware, and you're doing VBS, I would put the VBS stuff on the new hardware. Don't mitigate there's certain CPU vulnerabilities that if you mitigate them, you absolutely tank the performance of nested virtualization, VBS, that sort of thing. The MCE machine check exception, I can't remember what PSC is. If you it's not mitigated by default. If you mitigate that, your VBS performance will be bad. I'll just tell you that. If somebody exploits MCE PSC, all they're going to do is crash the host. And most attackers don't want you to know that they're there. And so they don't want to crash your host. And so nobody is exploiting that. So, check it out for yourself, but that's effectively what's going on there. So a credential guard is not retroactive. When you turn it on, it doesn't magically copy secrets into the secure enclave. It only does that when the secrets are created or stored the first time. And so you want to turn it on as soon as you build a new VM. You turn it on right away so that any secrets that are created as part of configuring the VM, installing applications, that sort of thing, gets stored there. And, heed the warnings for domain controllers, because, it's not storing a lot of the secrets that a domain controller has. And then pass-through devices, because it's nested virtualization, you can't pass virtual devices. You can't pass devices through. So if you need a GPU or something, you might have to shut VBS off. And that's actually a physical hardware limitation. There aren't enough layers. There aren't enough levels of the indirect page tables in the CPUs in order to do this in a very performant way. And so, until Intel and AMD and other CPU manufacturers add more there, which is up to them, then this isn't going to be likely. But virtual devices, a lot of that stuff can be virtualized now, and including GPUs. And so I would check that out. As a reminder, just some housekeeping here. If you're joining us, you joined us part of the way through. We're streaming in 4 different places. An archive of this will be on the YouTube channel, the VMware vSphere YouTube channel. And so if you have to leave or you missed the first part or whatever, no problem, and so you can catch that. We're going to go until we're done here. This is going to probably be a 90-minute session. So that's cool. Talking about workloads, protecting Active Directory. That's sort of our guinea pig for our example for protecting workloads. But a lot of these techniques are applicable to all workloads. And so if you've got comments, questions, the whole point of a live stream is that we can answer these questions live. Put them in the chat. We've got questions coming in from LinkedIn, from YouTube. If you don't see your question, I don't know about Facebook and Twitter. If you're asking a question or replying to something and it's not coming through, it's only usually a couple minutes until I answer the question. So come on over to the YouTube side of things. I know that works. And ask it there. So I appreciate you all. Thank you for coming, by the way. So and thank you for supporting us. And yeah, there's I mentioned upcoming things. We'll get to the end and I'll talk about what's upcoming. The VMUG Security Day on Thursday, and then another talk next week Thursday too. Let's get back to VMware tools. In-guest decisions. So I said I wasn't going to really get into the internals of Active Directory, but let's talk a little bit about it. There's some things that we can do. One of the things about tools, and this kind of came to a head this last summer with one of the security advisories. It was a low criticality security advisory. I think it's CVSS score of 3.8 or something, where an attacker had found a way to defeat the authentication mechanism. When you do stuff through the VMware tools to a guest operating system, it will prompt you for guest operating system credentials. And an attacker had found a way around that, and so we patched that, but there's a lot of different layers of protection there. But, that's a concern. We don't want attackers to be able to get into workloads. Again, the malicious admin sort of thing, and so that's troublesome. We patch it, but you also need to make sure that you're patching VMware tools and things. Put that in your update process. And I think the latest version is 12.3. Don't quote me on that. 12.3 or so. But and there's new features and functionality that are added as well. But how you do that is important, and there's guidance in the documentation for that. One of the things that I'm really worried about, though, is when you customize a VM, you've got this option to change the administrator password, for example. What if somebody cloned your VM, cloned your Active Directory domain controller, and changed the admin password? Is that possible? It might be, like for other workloads, it's absolutely possible, and changed it so they can get in. That's not cool. They can also run a script as part of the customization process. And so this is good. You want to run scripts when you're first deploying a new VM, right? Because you want to join a domain and all that stuff. By the way, vSphere 8 update 2 added the ability to, when you're customizing a VM, to add an OU and to the domain join stuff. And that's super cool, very helpful. But you want to do this the first time, but you don't want to do this after the fact, because what if somebody added a command like the net user command to change somebody's password so that they can get in? That's not cool, And so there's a bunch of stuff. The security configuration guide outlines a number of things that you can do to tools to help curtail this sort of thing. There's some pros and cons to everything. There's trade-offs. You can shut off the auto upgrade features so that you control that, especially if you're using another tool to do that, some software patching tools and stuff like that. You can shut off the enable customization, which I recommend once a VM is deployed, so that it can't be re-customized. App info, if you're not using app info as part of ARIA operations, I almost said vRealize operations, but now called ARIA operations. If you're not using the app info stuff as part of that, then I would suggest shutting it off. Shut off anything that you're not using. And then you can disable all guest operations as well by just running that command. We've got a whole bunch of stuff in the vSphere security and hardening guide, security configuration and hardening guide. I released a new version of this last Thursday. In fact, it's got audit scripts now. It's got a whole bunch of stuff. So if you're interested in hardening the VMware tools, and I think you should be, and VMs in general, this has got all of the technical, the nerd knobs, as I like to call them, the nerd knobs that you can tune and tweak and set to 11 and whatever, So speaking of nerd knobs, basically if you're running Windows Server 2012 or newer, and I hope you are at this point because 2012 is end of life, like today or Thursday or something like that. You'll get this Hyper-V generation counter, and yeah, it's Hyper-V. Microsoft got to name it, so they call it Hyper-V. But this generation ID prevents the USN rollbacks that used to happen when you took a snapshot of a VM or a DC, or you had to restore it from backup or something like that. You get these situations where they get out of sync and they didn't know where they were in relation to each other. So a domain controller might not have a full synchronized copy of the domain information. And so this is how Microsoft decided to fix it, and we support it completely in Windows Server 2012, and I think it's VM Hardware 13 and newer, that sort of thing. So yeah, definitely keep up with that. Sergey, remind us again, we're pleased where that file is. I'll remind you at the end, it's out on core.vmware.com. Here, maybe I'll type it in the chat here. HTTPS, I'll put the redirector, via.vmw.com/SCG is where I'll put that out in the chat for you there. Is where the security configuration and hardening guides are. So get asked about paravirtualized devices from time to time. Paravirtualized devices are definitely recommended by VMware, and they're about 40% faster. Why wouldn't you want 40% extra capacity or 40% faster stuff? Here's the thing too. Linux has had VMXNet 3 and PVSCSI drivers for ages and ages. The Windows install media from about a year ago until now and moving forward has VMXNet 3 and PVSCSI built into it. So if you're building new VMs, go get the latest ISO image from Microsoft and build it with that, because you don't have to do all the trickery with switching the SCSI adapters and all that stuff, or slipstreaming the drivers into the install or whatever. It's there. They're part of Windows Update. You don't even need to install tools. And so, yeah, just a little tip, but that's super helpful. Speaking of little things like that, a couple other things while you're building Active Directory DCs, separate your file systems for databases, for the database, for the logs, and for sysvol. Create three, have a boot volume, and then, like I always call it, I have a D drive, I have an L drive, and an S drive in my lab. Well, actually in my former life as well. And this is a tip that I got from a former coworker, Joe. Thank you, Joe. Because Active Directory, it writes through. It doesn't enable any caching, and so it writes through anything that's writing to disk. It will wait for acknowledgement from the whole disk subsystem that it's been written to disk on the back end before it proceeds, and that's a data integrity thing, and that's good. But when it's doing that, that means it shuts off caching for those volumes. And so you might want caching for your boot volume, for example, and for your other stuff, just to make the whole thing run a little bit faster. You can also manage the space better that way too. So if you're worried about sizing, speaking of sizing, memory sizing, look at the LSAS process database cache hit percentage. If that cache hit percentage is relatively high, that means you get enough RAM allocated to your VM. And if you don't have enough RAM allocated to your VM, then that cache percentage will be low. It's going to disk for everything. And for proper performance, you want to be able to, you want that stuff served out of memory as much as possible. A big environment, that might not be true, but a big environment, you can also afford to have more RAM on your DCs, your virtual DCs. RE Operations has got an Active Directory endpoint monitoring pack, which is actually kind of helpful. It monitors for the cache hit percentages and things like that. You might want to try that if you're a VROPS or ARIA operations customer. And then use the newest version of Windows that you can, 2022, that sort of thing, because everything just gets a little bit better. And I know there's differences and things like that and standardization and that, but in general, you want your Active Directories to be using the newest security features, have all that stuff turned on, that sort of thing, because they're important enough that you should be able to justify making an exception. So let's talk about infrastructure and design, what we can do in some of the infrastructure at the vSphere level to help protect these things. A lot of availability things. But first, actually, something new in vSphere 8, memory zeroization is what I call it, mem eager zero. The idea that, with CPU vulnerabilities and memory controller vulnerabilities and all kinds of stuff, that encryption keys and secrets like passwords and authentication information and whatnot are going to be held in memory on an ESXi host. Anytime a VM is started, the memory that's underneath that VM, is cleared out, is zeroed. But when a VM is shut off, that memory is not necessarily zeroed. And with CPU vulnerabilities and whatnot, you might be worried about being able to retrieve keys, or an attacker might be able to retrieve keys from another VM, copying memory in and stuff like that. You can turn this on, and when the VM is shut off, it'll zero the memory out there. So it might actually take an extra little bit of time when you shut a VM off before it's off. You'll see the guest operating system come down, but then it won't report as off until it's done zeroing the memory. So if you get a terabyte of memory on a VM or something like that, it might take a little bit. So just keep that in mind. This is also in the security configuration guide. Copying keys, encryption keys like this, and secrets in memory, that's actually something attackers are starting to do. And so it might be worth checking out. Other things that you can do to protect your VMs. I don't want to talk about NSX too greatly here. NSX is like the old school, the OG microsegmentation thing, feature, product, whatever. Being able to microsegment stuff is super cool, and firewall stuff at a very granular level, and be able to change it dynamically is nice. And it's got distributed IDS, IPS in it. Of course, this is only looking for things that we know about, and so attacks that we don't know about or that you let through, or RDP coming through from somewhere, somebody at VMware Explorer, one of the NSBU guys, the NSX guys, in fact, mentioned that RDP's nickname is Ransomware Distribution Protocol, which made me laugh. And again, additional things to help you. Is it the complete solution? Not necessarily, but will it help? Yeah, absolutely. Other things that'll help: VLANs, old school segmentation. VLANs are not really a security control, but they're an isolation control. And they can help with stuff there. Make sure that you're not running a default VLAN. Your trunk ports don't have a default VLAN. There's a lot of security implications to that, and we cover that in the vSphere security configuration guide, for example. One of the things that you can do with a port group, and people don't really realize it, the distributed switches have this traffic filtering and marking, and it's more like ACLs than anything else. You can do it on a port group level. And so you can set up an ACL. ACLs kind of stink because they don't have reflexive rules, or not stateful, that sort of thing. But if you want to protect things and you don't have NSX or whatever, might be an interesting option. And I will also say, and so you can only have one set of rules per port group, but you can have multiple port groups on the same VLAN, for example. So, it's actually fairly flexible there. So just a tool in your toolbox. That might come in handy at some point. One of the other big things about design is be smart about placing your dependencies. Active Directory, if your Active Directory DCs, speaking of physical stuff, George was talking about physical domain controllers, and I got into this a little bit. But if your vSphere environment depends on your Active Directory for something, how are you going to start it up if it's a circular dependency? So some physical stuff might be important. I used to create, in fact, my lab is set up this way right now, where I've got a dependency host. It's just a single ESXi host, and it's got one ADDC on there. It's got a KMS on there. It's got a DNS resolver on there, and that can boot first as a dependency host in each of my sites, that sort of thing. And so that's how I get around that without having explicit physical hardware for everything, that sort of thing. But having more than one critical component in a site, that's especially important. I'll talk about traffic tromboning and problems with multiple site, hybrid cloud sorts of deployments and things in just a second. Replicating the critical components between sites, super important. You want a couple of ADDCs in each of your locations, and so that your workloads don't have to go very far to be able to, very far across the network. You're talking milliseconds here. You don't want your dependencies, your Active Directory, your DNS, your NTP to be that far away from your workloads, because that slows the workloads down too. But and you want to be able to patch each location. Sure, you can have failover between the sites or whatever if there's something catastrophic going on, but you don't want each location to. You want to be able to patch one location and still have service at that location, not impact the latency for your workloads. And then the question before, and we've kind of been dancing around this. One of my favorite questions of all time has always been, what happens when it's all off? Like, what are the dependencies? Because sometimes when you ask that question, you get answers you don't like. And so, yeah. So I want to talk a little bit about any multi-site configuration, hybrid, cloud, whatever. You've got this, you've got these VPN links. Stuff is coming in via the cloud. Maybe you're moving stuff up to the cloud or moving stuff to your DR site. Maybe you've got a site in Chicago and a site in Kansas or something like that in the U.S. And a few 100 miles, 500 miles apart or whatever, and you're moving stuff around. Well, unless you know something about physics and the speed of light that I don't know, those distances have latency associated with them, and it's fairly linear, and so, if you've got traffic that's coming in and it has to go back to one data center and then go to the other one, that's trouble. The figure, my scrawling here, my graphics or whatever, but if you got to go out and come back, that's if it's 60 milliseconds one direction, that's 120 milliseconds round trip, right? And that stuff starts adding up, especially if the application that's at, or maybe it's Active Directory or whatever, is at the other site. It's come back to the new site, and maybe it's got dependencies. It's got to go back and do this traversal as well. So now you don't just have one 60 millisecond thing, you've got 4 different 60 millisecond trips. And now you're starting to see applications slow down. Authentication gets slower, and you wonder, this hybrid cloud thing really isn't for me, or whatever. This isn't working. Well, you need to straighten that out a little bit. And even if you add firewalls, even if they're really fast, modern firewalls, they add a couple of milliseconds either way. And so this stuff really starts adding up and really starts hurting. So having an Active Directory domain controller, for example, and DNS and all that stuff available in each site so that the traffic is simplified, even just for troubleshooting purposes. Things go a lot faster. It's easier to troubleshoot, all that stuff. So I mention it, just as a design point, that sort of thing, but something to think about, because I've talked to a number of customers that have had, they've moved things between sites or whatever, and they're slow. Why is VMware Cloud so slow? Well, it's not. It's all of that, and so other things that vSphere can bring to the table here, a lot, especially around availability. HA DRS, turn on DRS, the Distributed Resource Scheduler, and it uses vMotion. You can tell it to keep your Active Directory domain controllers separated, so that if you do have a host problem, you don't lose all your DCs at once. Perhaps you might only lose one at a time. And when you're setting it up, what I also have done in the past to great success, if what happens when everything's off? Well, if you've got to go and turn one of these things on, you don't want to have to search through your entire, maybe you've got a 32 node cluster. You don't want to have to go to 32 different nodes to try to find your Active Directory DC. So I always created a rule to pin them to a particular host. And so, my primary Active Directory domain controller should be on, it was always alphabetically the first host that was in my vCenter server list or whatever in my cluster. And so I always knew where it was, and I wasn't searching for it. But when you do this, and I'd recommend you do it, I really like this idea. When you do this, always use the should. Don't use the must run on hosts in this group, because that'll interfere with patching. And what happens when you interfere with patching, you'll go, oh, that sucks. So you go in and you'll shut DRS off, or you'll disable this rule, and then you'll forget to turn it on again, and I'm guilty of this all the time. And because I always say one of the biggest lies that sysadmins tell themselves is that we'll go back and fix it later. No, we won't. We're not going to remember. We got too much other stuff going on. So you should, and DRS can move it, and then it'll put it back afterwards, because it should be there, but it doesn't have to be there, that sort of thing. Availability settings, HA, high availability. vSphere HA is cool. If a host goes down, it'll restart all the VMs elsewhere where there's capacity. Make sure these defaults are set correctly for your environment. Out of the box, they're not set correctly for pretty much anybody's environment. It's a compatibility thing, but go in there and make sure that it's going to do what you want it to do when it detects an outage. And you can also change how it detects an outage. The VM monitoring, for example, maybe you want it to talk to VMware tools for a heartbeat, and when there's not a heartbeat, you want to automatically restart it, that sort of thing. So there's that option as well, and so that's pretty cool. Another thing for Active Directory domain controllers is the idea to reserve all of the guest memory. What this will do is it won't allow ESXi to swap out RAM. So if you've got 16 gigs of RAM allocated to your domain controller, that 16 gigs of RAM is guaranteed to the domain controller, to that VM. Should you do this for everything? Probably not. But things that are critical infrastructure like this, memory overcommitment is not a real good idea in general. But sometimes you might get into situations where it happens, where you're doing a little bit of paging. If you're paging your dependencies, if you're swapping your dependencies out to disk, that's going to make for a really bad day, because everything else is going to get slow, for the same reason that we were just talking about the traffic tromboning and stuff like that. By the way, traffic tromboning, I think that was a packet pushers term. Greg Farrow and crew and Ethan Banks and whatnot. Great. If you're into networking, great podcasts and stuff like that. I'm pretty sure that they came up with that traffic trombone term. But at any rate, when we were talking about that in the latency, anything that introduces latency to your dependencies, like an Active Directory, is going to be trouble. And so, consider doing this. But there's this latency sensitivity setting, and this does not affect network latency. And when you set it to high, when you set the latency to high here, it deprioritizes all the rest of your workloads. It might just be better to put your domain controllers closer to your workloads, size them more appropriately, add more CPU, RAM, that sort of thing. And so be careful with this one. Be very careful. With vSphere 8, when you set it to high or high with hyperthreading, it exposes underlying hyperthreading structures and all that to it. That's a rabbit hole that you can go very deep on, that most organizations don't need to. Let ESXi manage that for you. If you're having problems there, add more resources to the cluster. Standalone dependency hosts, like what I was talking about earlier, you can actually set up so that the VMs come up automatically. You can't do this in a cluster, and you can't have automatic start. HA takes care of that, is what it amounts to. But if you've got a dependency host, like I was describing, where it's just a standalone host that has some of the data center dependencies, then this might be a good option for you. Getting towards the end, I want to talk about a religious topic now, time synchronization, the church of the clock here in Active Directory. And there's a lot of opinions about time synchronization and things like that. And I've always liked this. Everyone likes to blame DNS for things. There's no way it was DNS. Oh, yeah, it was DNS. And I always used to say, except when it's NTP, NTP, time synchronization, problems with time synchronization also cause a lot of weird delays and errors and things like that. And when you get all your time synchronized, that's really nice. But I work with a bunch of smart people, and not in the intelligent perspective, a bunch of sarcastic types of people, and they came along and said, well, except when the NTP servers aren't resolvable, then it's DNS again. Thanks a lot. Thank you very much. Anyhow, they're smarty pantses. Anyhow, So time synchronization, there's a lot of advice out on the internet, and I would posit that it is not 2005 anymore. A lot of that guidance is really old. And again, when you use more modern operating systems, modern copies of Windows and things like that, there are better options for things. So one, universal truth, don't sync the guest time to the host. We've been saying that, or if you're doing that, maybe there's a disconnected thing that you're doing. Some folks a few years ago were building data centers in a truck, for example. Syncing the time to the host sounded like a good idea then. But in general, don't sync the guest time to the host, because if the host has incorrect time, it might still affect the guest operating system. Well, it will definitely affect the guest operating system there. But also make sure ESXi is set correctly, because if you vMotion, VMware tools will still sync the time sometimes. vMotions, snapshot reversions, all kinds of, there's a few things. These really old KB articles, look at the numbers on those, 1189, 1318. Those have got the situations where VMware tools will still sync the time. And you can shut that off if you want to, but you might not want to, but just make sure ESXi is set correctly. And then monitor time inside your guests. It's very educational when you monitor time inside your guests, that you see a lot of drift, that sort of thing. But it's worth making sure that it's within 5 minutes or so. So other things about time synchronization, I guess I should have labeled this 6, 7, and 8 here. Well, 5, 6, and 7 rather. IP addresses versus fully qualified DNS or fully qualified domain names, DNS names. That's up to you. If you use DNS entries for DNS names for your NTP servers, then you need DNS to be operational in order to use them. If you, and so it can be troublesome. Recommendation is always 4 NTP sources. And you might say, hey, I thought the recommendation is 3. Well, 3, any cluster situation is n+1, right? In a cluster situation, 3 nodes is really 2 nodes, so yeah. And there's Siegel's Law, I believe it is. Siegel's Law says a person with 1 watch always knows what time it is. A person with 2 watches has no idea. And because which one is right? They're all going to drift a little bit. So you need 3, and in order to have 3 working ones, you probably need 4. Especially if you're using public sources, which we'll talk about in a second. The PDC emulator might be a single point of failure for you. So if you've got old stuff, well, one, upgrade it perhaps if you can. If you can't, you're going to have to protect that a little bit more as well. So something to think about. So when you're configuring Active Directory time, you're going to need to, and again, running a time source inside, well, not again, but to note, running a time source inside a virtualization environment means that time source is going to drift. So if you need super accurate time, you should go out and buy a $150 external GPS-based NTP server that you can put in your data center or put on your roof or whatever, and do it that way. They're not that expensive, and they're worth it if you need accurate time. Because again, running it inside of a VM is not going to lead to, it's like running NTP in a VM. That's not going to end well, that sort of thing. For synchronizing a client, it's going to be perfectly fine. For precision time, and we do support PTP as well, by the way, but for precision time, yeah, think about that pretty hard. But anyhow, you can say whether you want to get your time from the domain hierarchy, whether you want your time to come from the manually configured sources, or from all of them. And again, I tell you, what happens if it's all off? There might be a situation where all your DCs are off, or some of them are unreachable or whatever. If you could plan for it, you would avoid it, right? But yeah, leave yourself some flexibility when you're designing these systems. All seems like a good option. And so something like this, where you're configuring a bunch of different sources, but you also take into account, it's all just data points. And the Windows time service does a really good job of synchronizing and keeping things in sync this way. And you can query it with the peers and status there. I will say that if you're using PowerShell, make sure you use sc.exe, because sc is a shortcut for something else. And in PowerShell, and it means something else. So don't just type sc space config, do sc.exe space config, that sort of thing. I will say that UDP ports that are open, in order to use public sources, you need to have UDP ports open to the internet. They're often used to exfiltrate data. Something like 25% of all attacks now, the attackers are using DNS to exploiting DNS, the lack of egress DNS firewall rules to and NTP rules to exfiltrate data to their own systems out on the internet. So you need to, if you're security minded, you need to restrict access to public DNS servers and NTP servers, that sort of thing. Egress protections are really important. And so that probably means for most larger organizations that you're getting time, the $150 time sources, you're going to get 3 of them. You're going to put 3 of them in each site, that sort of thing. $500 to not have all your data exfiltrated over the internet sounds like a good deal. This also carries forward for your clients. Should your clients rely solely on Active Directory for time? Maybe they get the all treatment as well. It depends on how you want to configure them and that, but clients are a little out of scope for this talk at least. So resources, getting to the end here. VMware, the VMUG Security Day coming up on this Thursday. All day long, it's like 7 a.m. Pacific to 5 p.m. Pacific or something like that. And it's out on vmug.com. If you just Google for VMUG Security Day event, you'll find it. You'll get the link there, that sort of thing. We're having another talk in next week, Thursday, October 19th. We'll talk about actually attaching vSphere itself to Active Directory, to Okta, to Azure AD, that sort of thing. And my coworker, Viviana Miranda, will be leading that one, and that'll be really cool. She's been doing a lot of great work with that, and so keep that in mind. The security configuration guide, I already put it out. It looks like it went to the Facebook and the YouTube sides of things, but this is the URL for it if you're interested. Also a QR code. Should you scan a QR code off the internet? How much do you trust me, really? And I'll say it's even twice as bad because, or maybe it's exponentially bad, times 2 bad. Because it goes to a redirector. Where does that redirector go? Well, as it turns out, it goes to core.vmware.com. So, but yeah, use your head. If you do nothing else today, please sign up for our security advisory mailing list. If you've seen me talk before, you've heard this a million times. There's no marketing on this list. It's just bad news. I call it the most negative email list that we have at VMware because it just sends you bad news that there's a vulnerability, but you need to know it, and VMware tries to be very transparent about this stuff because hiding it doesn't serve you very well. And we're interested in keeping you safe. So yeah, sign up for this. Do this for your other vendors, not just VMware as well, but sign up for all vendors. Sign up for the Microsoft one as well. And other resources, core.vmware.com is our site for technical resources. Folks like myself put a lot of content out there. And so you can go to, there's compliance. If you go to the solutions menu there, you can go to, there's compliance, there's security, there's ransomware resilience, there's all sorts of stuff. So with that, I thank you. If there's any final questions, get them out there soon here. Otherwise, I bid you adieu. I thank you very much for joining us. Please stop by the VMUG thing. I've got 2 talks on Thursday here at the VMUG Security Day, and one on hardening. It's a subset of the talk we did last week on hardening, and one on professional development, how we can get roped into the security stuff and how we can transmute that into better pay and new jobs and things like that. And so, yeah. So thank you all and take care.